scikit-learn machine learning models in the cloud.
Hi everyone, I'm Alex, and this is my third time at PyCon here in Florence, but my first time as a speaker. So I'm happy to share with you my ideas about machine learning, about cloud computing, and basically how to get the most out of both worlds while keeping your deploying strategy as simple as possible. Just a little bit about me. So I'm a computer scientist and a software engineer. I've been working in web development for a bit more than 6 years, and I happily joined Cloud Academy about 3 years ago, where I started using Python. So recently I had a chance to create and work in a new internal project where we focus mostly on machine learning, data analysis, and artificial intelligence. So I don't know if you have ever met a real data scientist. In case you haven't, I'm glad to introduce you Bob. Okay, who is Bob? He's a data scientist. He happens to lead and work in a very skilled team of data scientists too. And he already built great machine learning models. Of course, he loves Python. There are many great tools in Python to do such models. And in particular, Bob really likes to build a smart application for the final user. So he likes to focus on the final customer or products, which is not always the case when you build machine learning models and when you analyze data in general. So making an application smarter and improve the user experience is a very interesting field of machine learning. So what did Bob do so far? Well, he created a model. How do you create a model in Python? Let's say we want to build an offline model with scikit-learn, for example. More or less in 20, 25, maybe 30 lines of code, you can train your model. At some point, you can test it, see if it works. Let's say in this case, I was building a classifier, so I print my confusion matrix. I see if it works. Main diagonal is good. I like the model. And what you usually do as a data scientist, maybe you want to serialize your model to files so that you can use it in production or somewhere, wherever you like. So you will think, okay, my job is done because I built a model, I documented that it works pretty well, I have a good accuracy. But how do you put it in production? How do you integrate it with a real complicated environment and maybe a distributed website or whatsoever your company needs? So I want to show you why this is complicated and why you should be able to have complete ownership of what you're doing while deploying your machine learning models, because you want to update them, because you want to see what they're doing, right? So why is this a challenge? I think first of all, what you need if you do user-centric machine learning is you want to scale at some point, because hopefully your clients, your customers will be a lot over time. They will grow over time, and so you need to have a way to be elastic in your compute power. So if you use scikit-learn or something like that, some people even think it's not production ready because it doesn't scale, because it's not GPU optimized, and it's really hard to build distributed computing if you already have a very nice model in scikit-learn. And even building infrastructure-aware code is not as simple if you're not a DevOps or something like that. It's fun, but as a data scientist, maybe you don't want to. You want to focus on your beautiful model. So second of all, I think it's not just about the model and its accuracy. You also want a full set of features that, you need to code them, you need to implement them. So for example, you don't want to have one model, maybe you want to have 3, 5, 10 of them. And for each of them, maybe you want to A/B test them to track what's working, what's not, to improve the system over time and have multiple variations of your configuration maybe. What else? Well, maybe your models need to be accessed by many clients, many different systems. So maybe you want to offer and expose them in a RESTful API. And so you have a RESTful API, you need authentication, authorization. How do you integrate that? And maybe you are a data scientist, you don't even know how to implement that. And you want to be independent in your development and deployment strategy. So let's see how we can do that. That's the third problem. We are not DevOps. I'm a software engineer, but I don't really like operations. Bob doesn't either. I don't know about you. So I don't like, Bob doesn't like to maintain a server, to patch them, to update the operating system, to deal with continuous delivery. And okay, automation is fun, monitoring your data is fun, but I want to work with data, not with machines and operations. And the opposite is true as well. They're not data scientists. So there is like a totally different skill set. So Bob can design a perfect model, train it, test it, develop his own data pipeline, and if you are in a big company, you can't expect your colleagues to understand what you are coding, because maybe they can help you with the syntax, with the beautifulness of your code, but you are the owner of your code, and you should be able to be independent, as I said. So this difference in the skill set generates a lack of ownership, because you can't do whatever you want with your code. You ship it, somebody else will take care of deploying it, and sometimes it's not the best solution, I think. So let's see what are the possible strategies and how we can improve and remove this lack of ownership in the process. First version of our strategy. Let's say we want to, we have our model, we serialized it into some kind of file in a local file system. Maybe we pickle. Here I use the pkl extension. So I can implement my little controller that allows the model prepare the input, predicts the output, and just return a JSON. This is a simple controller. This is Flask. You can do the same in Django and in every other web framework. So what's the problem here? What's the problem? It's really simple, but how do you update the model? How do you keep it updated? Do you have to redeploy the whole web application? Do you really want to use the same authentication and authorization mechanisms and layer that you have in your own website? Do you really want to use the same shared resources, so the same process, the same RAM, the same CPU of your website? Because, okay, this is user-centric, but I mean, this shouldn't slow down your whole website. So maybe you want to make it a little bit more independent. And okay, the first thing you can do, okay, let's add more servers. Let's add more processes. Let's add more capacity to the system. That's what you usually do in a web application. You want to scale up. So now we have better capacity. We didn't change the code. Looks good. We still have the same problems like model update and versioning and staging. But still, as a data scientist, I don't want to handle even more machines, even more DevOps stuff. We don't have elasticity. We just increase the capacity, but we're not elastic at all. We have more processes, say 5 per machine and 10 machines. We are still stuck at 50 executions in parallel, which doesn't scale. Okay, let's get better. Auto-scaling, what's that? I don't know how many of you knows like Amazon Web Services or Google Cloud Platform. You have tools now that allow you to scale horizontally in a kind of automatic way. So here I'm mentioning Amazon ELB, the load balancer, and auto-scaling, which are 2 services that together basically allow you to scale horizontally. We still didn't change the code. Okay, we still have shared resources with the website, but at least we are elastic, right? I feel this is even a bigger lack of ownership, because now there are an undefined number of machines which I don't have access to, which I don't have control over the deployment at all. It's still in the hand of DevOps. I don't like this. And also, what about the other features? I still have to implement them. Caching, versioning, authentication. It's still integrated in the website. I would like to find a solution that allows me to be independent from all of that. And there we go with my favorite solution, which is serverless. How many of you have heard of serverless in the last 1 year or something? Okay, cool. So serverless means, it doesn't mean there are no servers. It means you don't have to deal with servers when you code your own business logic. So for example, with AWS Lambda, it's a service that allows you to build your little function, and basically you deploy it as a single function in the cloud, and Amazon manages everything else. So basically they use containers. Maybe you know about that. And basically you can deploy these little functions that do whatever you want. And I think this is pretty good for the application of machine learning, because what you need to do is you have an input, you process it, you have like a set of features, you need to do some magic and return the output. You have a classifier, you have a predictor, whatsoever. So the logic is really simple. What you basically need is to scale up and to keep it simple. What do we gain here? We have infinite scalability, meaning we don't have to deal with that. We just pay for whatever invocations, for the total number of invocations. It's a pay per use, a pay as you go, as I say. What else do we gain? We have a global content delivery network, which eventually provide also caching, because with Amazon API Gateway, it's another AWS service, you can basically have a RESTful interface which automatically implements authentication, caching, eventually staging. You want to have different stages like dev, prod, whatever. What else do you get? Well, Amazon API Gateway uses CloudFront, which is another service, to provide you with even, I think, more than 60 edge points around the world to be as close as possible to your users. So eventually, if you want to expose your machine learning model to publicly, like from the browser, that call is cached and as fast as possible. That's a plus. You have an authentication layer completely independent from everything else. You can use like header keys, you can use IAM, the specific Amazon identity service. And you also have versioning. In fact, you can version API Gateway resources and Lambda functions in a separate way. So you can do really whatever you want. So what's the takeaway here is, of course, there is a server. I don't want to deal with that at all. I don't want to worry about it. It looks nice. It sounds nice, maybe. I hope. But how does the code change? What do you have to do in order to be compliant with how do you deploy a Lambda function? So that was our code. Very simple, our little controller. Well, it doesn't change much. If you look at it, you basically have your Lambda handler is just a function that gets an event and a context. That's like the signature of your Lambda function. And provided that your input pipeline processing is the same and your output is the same, because it's automatically encoded as JSON with API Gateway, basically no change, right? It looks good and it scales automatically. But we still have a problem. How do you update your model? Because here, basically what you have to do with Lambda and API Gateway is you have to deploy each single Lambda function individually, and like this, I'm loading a local file. So I'm still stuck with my model. If I want to update it, the only way is I redeploy the Lambda function, which is okay. It's not too hard. You can do it in 3 clicks, but it still gets some time, and I want to automate the process, and I want the Lambda function to be automatically updated as soon as I have a new model or a new A/B tested version of it. So let's see how we can improve this. It's a little bit more of code. So previously we had this load model, which basically was one line. pickle.load, I was loading from a file. Very simple. Now I can do something more complicated, and basically, for example, I can load my model from an S3 bucket. S3 is the AWS object storage service, and basically you can put whatever you want in a key in a file, let's say, an object, And good thing is you can version these keys in the cloud. So I have my model.pkl on on S3, and I can periodically, even on each invocation, check if that file has been updated or not. So what I have to do to deploy a new model, I upload a new file on S3, and my Lambda functions will get the new model. In this case, I'm doing this at every Lambda invocation. So I check if there is a new model. If there is one, I just download it and use it for the very next invocation. No downtime, still super high scalability. If my service, if Lambda was serving 100 requests per second with 5 containers, they will all get updated automatically. That looks good. One downside, you have to download a file, and maybe the next invocation will be a little slower, but my hint is, well, you can use maybe gzip. I don't know, if you have a huge model, a few megabytes, that takes a little bit, like a few seconds. But with gzip, you can eventually stay in a reasonable range, maybe a megabyte or something, or even less. So does this work? It's not theory. If I'm here, I'm glad to tell you that it works. And I'm happy to share with you what we've been developing at Cloud Academy for our own internal project. So you can find a link. It's a little bit small here. But what do we have? We have our own applications, so the website and the mobile app that track a lot of data. So we have a data collection pipeline that streams the data inside our database, data warehouse inside Amazon. And there is an EC2 instance that periodically retrieves that data, trains a new model, and then uploads it into S3. What does it mean? So far nothing, but our app and website also calls Lambda functions through API gateway every time they need a new prediction. Let's say you want to retrieve a recommendation for a content. We basically have content like courses or laboratories, and we want to provide personalized recommendation to our users. So every time we need that, the app or the website call Lambda function, which corresponds to a model, which corresponds to a file on S3, and automatically you get an answer. I can tell you this is really scalable and elastic. I can get a prediction in less than a millisecond. Lambda is really incredible. And it also supports Python, only 2.7 so far. Let's see what they do in the future. And so what happens? How about versioning? I have a new version of my model, no problem. I create a new Lambda function. I call it version 2 or something, and I bind it to another S3 key, and I'm done. All I have to do is tell to my applications, to my client, basically, to call another Lambda function, and I don't need to be backward compatible or anything. So what's the difference with our first version? I don't need DevOps. I can do all of this by myself. There is a beautiful console that I can use, and so I mentioned A/B testing also. Internally, we decided to use a server-side A/B testing framework. Maybe you know it. It's called Sixpack, and it's really interesting because it's based on Redis, so you can, in practice, A/B test your Lambda function variations, or you could potentially integrate the A/B testing directly inside the Lambda function and load 2 different models based on the variation that's selected. That's really up to you. We decided to delegate this to the client, but you could integrate this into Lambda functions. One drawback here, Lambda functions so far requires you to deploy your few lines of code. Could be 20, it could be 100, it doesn't matter much. The problem is here we have some dependencies. We need scikit-learn, we need NumPy, maybe pandas, a lot of code that you would handle in this case with, I don't know, your requirements file in your project whatsoever. Okay, with Lambda it's a bit harder because you need to upload in your deployment package like a big zip file with your source code and your dependencies. That's a bit uncomfortable, I think, but they're working on improving it. So what do you have to do? Well, you have to provide scikit-learn, NumPy, pandas, all compiled in their own infrastructure, like CentOS, I think, and basically upload everything into Amazon Lambda. That's really easy to automate. I don't need a DevOps. You write a little script and you're good. What else to say? So the download of the model takes just a few milliseconds, and actually we never download the model more than once, because actually all the code which is about the Lambda function is executed only once. What Amazon Lambda does is they create a new container to initialize the service, and then every time the Lambda function is invoked, they just call the Lambda handler. That's very easy. So if you have some initialization code, like some file to download from the S3 or wherever, it's not affecting the invocation itself. What about the version check? Okay, you have to call S3 and check the version, but it takes really just a few milliseconds because Lambda is executed inside AWS, and calling S3 is really, really fast. So not really any performance issue here, because in my example here, my model takes, I don't know, 2 milliseconds to execute and 10 milliseconds to call S3. I could be faster, but 10 milliseconds is still really acceptable, I think, if you can scale horizontally without any problem. Okay, what about other cloud providers and platforms? Well, I'm excited about Amazon, but recently there have been a lot of other services announced and published by other cloud platform like Azure or Google Cloud Platform, even IBM, Bluemix. And unfortunately, none of them supports Python yet. But even Amazon Lambda took almost a year to support Python, so I would expect to see the same in the other providers. There are other solutions, more hybrid, where you can basically upload your little Lambda function, the same thing, but on a different way. Like let's say if you are already on Amazon Web Services, I would recommend to use Lambda because it's so much faster. But if you're not in the cloud, you could evaluate also the others. They are really interesting. I haven't tested them myself, but it will be nice to know if you have. What else? Well, I also tried Google Cloud Functions. It's a really good service. It's still in alpha preview, but I will suggest you to give it a try if you already use Lambda. And I even developed a little tool to switch between the two Lambda function services, so that if you already have Lambda function, you can switch to the Google Cloud Function. And it's not trivial, but you can do it yourself if you have time. Okay, I think I'm good. Thank you very much. And just a note: if you are, we are always looking for great Python developers. Just drop me a note if you are interested. We are hiring. Thank you very much again. Any question?
Hello.
Hi.
I have a very direct question. We have a case that exactly fits what you described. So we have models that we want to have uploaded and be updated automatically without caring about the things you listed. The only thing is that they don't rely just on Python, but we use RPy. So it's it's the library to have R integrated into Python, and so we need R installed in a server that runs these scripts. Is this feasible in this Amazon Lambda?
Well, I can tell you installing like system libraries and dependencies on Lambda is not as trivial. So what you need to do, for example, with scikit-learn, if you are using some, I don't know, C or Fortran dependencies, you would need to compile those Python libraries and include all the C and Fortran and everything else that's connected, because you can't, at the moment at least, configure Lambda to install external dependencies or operating system dependencies and libraries. That's quite a pain at the moment, and I'm not sure about our Python, but I will say it's kind of the same. So you will need to maybe compile it as a library and deploy with your deployment package altogether. I will need to test it.
And do you have an idea if we were to use R directly, so not Python at all?
I don't think so. Well, Lambda supports right now Node.js, Python, and Java. So everything that runs on the JVM could be potentially executed. So I'm not sure if that could help you. For example, if you want to deploy Ruby functions, you can do that with JRuby, which runs on JVM. So if you can find a solution that's compatible with either the JVM or Node.js, that could be a solution. Like before Python was supported, people were executing Python by running a compiled version from the Node.js interpreter. So you can do some hacks. I wouldn't recommend to deploy it in production, but people used to do it.
We have a great hacker here. Very specialized.
Thank you. Other questions?
Is there any timeout for any request that is made?
Yeah, there used to be a very short-term timeout, like 30 seconds at the beginning. Now you can run a function up to 5 minutes, and I think for most scenarios that's pretty enough. In case you need to do like some batch processing or some longer task, it's nice because in the context variable that you have, you see your Lambda handler as an event, which is basically the data that you send, maybe with a post request through API gateway, and a context variable. In that context variable, you can see how much time is left in that specific invocation. So you can check, okay, if there is not enough time to finish my task, you can trigger yourself in another Lambda function and keep working on your task. So that's a workaround. But if you really need more than 5 minutes, Lambda is not your use case. That you're not the use case for Lambda, maybe. And the interesting thing is that you are built for every 100 milliseconds of execution. So basically, if you are executed for 1 second, you are built like 10 executions and so forth.
Here I am.
Hi.
Can you also apply data encryption in place or any kind of algorithm to protect the transaction from your data to the server? Is it supported by this architecture?
Sure. You can do anything you want with the data. So if the client encrypts the data and sends it, well, here you can decrypt it with the same key or whatever library. If you use you would need to include your encryption library in your deployment package and deploy it all together. But sure, it's not integrated natively into API Gateway or Lambda, but yeah. More questions? Nothing. Okay.
So let's thank our speaker again.
Thank you very much again.